Welcome back, kiddos. We're going to take a few minutes, a very short video, I hope, to implement the solubility rules that we talked about previously. And in the process, we're going to be refreshing our memory on how to write chemical formulas and how to balance chemical equations. We are making the assumption in this unit that you know how to balance a chemical reaction. We'll be doing a lot of examples, so if you've forgotten that, you might want to come into tutorials or make sure you get a little bit of extra help from me. All right, let's first take a look at how we kind of parse out the terms in a written chemical equation. So let's look at some keywords here. We see the word a piece. If it says a piece, that means that we have solid piece of whatever follows. And it said zinc, so we write zinc as Zn. Since it said a piece of, we're going to put an S for solid. The word reacts with means adds, is added to in the chemical equation. Hydrochloric acid, hydroic came from ide, chloride is Cl minus, so hydrochloric acid must be HCl, and an acid by definition is an aqueous solution. Now, how we communicate the word produced. We're using symbols to communicate meaning here, and we're going to use an arrow to indicate produces. Now we have zinc chloride here, and in order to write the chemical formulas, before you at some point you're going to be able to do this without even thinking. But until then, what I want to recommend doing is put the charge above the symbol. So when zinc is pure, all by itself, not bonded to anything, it's got a 0 oxidation number. When zinc goes into a compound, it's +2. Chloride will become -1. So to write the chemical formula for zinc chloride, it's ZlCN2. Now we're going to need to put a state symbol there. And so let's take a look. If we go up to our solubility rules, you notice it says that all chloride salts are soluble except for silver. This is mercury 1, it's a weird one, and this is lead 2. So that means since zinc is not one of the exceptions, it's part of the solubility rule that says all chlorides are soluble. I'm going to put an AQ there. It's going to dissolve in the water. And then hydrogen gas. Don't forget your diatomics. And you should know hydrogen's a gas. We shouldn't have to tell you that one. Now, before we leave, what we want to do is make sure that we have balanced this. I have 1 zinc on the left-hand side and 1 on the right. I have 1 hydrogen on the left and 2 on the right. So I'm going to put a 2 in front of the HCl. Now I have 2 chlorides because that 2 applies to everything that follows in the chemical formula. So I have 2 chlorides there and I have 2 chlorides here, so that's now balanced. Okay, let's take a look at the next one. We have phosphoric acid, so we have H3PO4. Ic came from 8, so this is an acid based on phosphate. Acids are aqueous, is reacted with, I put the plus sign, a solution of, so I know that I'm not talking about pellets of sodium hydroxide that I got from the back of the room, but that I've already added them to water and made that homogeneous mixture, aka a solution. And that's going to produce, it says it reacts with, to produce, I'm going to get sodium phosphate. So again, write your charges above there. Sodium's +1, phosphate's -3. So you know you need 3 positive cations to balance out that -3 anion. And if you look up at your solubility rules, it says all group 1 salts are soluble, and there are no exceptions. We have water present because we're mixing solutions. So there's lots of water present, so that's aqueous. And then we're going to make water, and we use the L for liquid for the water as the solvent. And they're the only products. Okay, so those are our formulas and our states. Now we have to balance it. So I'm going to save, and I just happen to know this intuitively, but let me give you a hint why. You have hydrogen showing up here and hydrogen showing up there. I'm going to save it for last and hope it just kind of all falls into place at the end. The other thing that I want to point out is when you have a polyatomic ion that remains intact, it wasn't broken apart or decomposed, you can count it as one whole unit. You don't have to count that phosphorus and oxygen separately at that point. I've got one phosphate on each side, so I'm going to start with the sodiums. I've got one on the left and 3 on the right, so I'm going to put a 3 in front of my NaOH. And now I'm going to count my hydrogens and oxygens. I have 3 hydrogens here because that 3 counts for that. And I have 3 here, so I have 6 hydrogens. And I'm going to put a 3 in front of that to give me 6 hydrogens. That gives me 4 plus 3 oxygens is 7 oxygens. And I have 4 plus 3 on this side. So that's now a balanced equation. Now let's go on and do just a couple more of these, and hopefully that will reinforce it for you in class. And I'll talk about what these other aspects of the notes are in class. We're doing something a little different with those. Okay, so now we have chlorine gas. So don't forget that chlorine is diatomic. I bring clay for our new house, or Brinkelhof. So I've got chlorine. It tells me it's a gas. Fluorine and chlorine are gases. If you go down the halogens, it goes gas, gas, liquid, solid. Is bubbled through a solution of, so when you see solution and you know you're going to add an AQ. Lithium is +1, iodide is -1. So I've got lithium iodide, and that's AQ. And the products are, that means I'm going to put an arrow to get to my products. Lithium's +1. Chloride's -1. It's group 1. All group 1 salts are soluble without exception. It's nice to not have to look at the rules if you don't have to, but you will be given those solubility rules. Plus solid iodine. So I2 solid. And we've written out all our chemical formulas. Before we leave it, we want to balance it, something I will often forget to do because I'll get talking to you. And so if I put 2's there, that's a balanced equation. Let's do the next one. Silver nitrate. Silver is +1. Remember, it's part of that little steps that we taught you. Nitrate's -1. So silver nitrate is AgNO3. All nitrates are soluble without exception, plus it said a solution of. So we knew it was aqueous. Barium chloride. So I've got barium chloride, and again it said solution of, so I know it's aqueous. And it said the products are silver chloride. Well, silver's +1, chloride's -1, and so silver chloride's AgCl, and we've got to put a state there. And then I have barium nitrate. Barium's +2. So barium's group 2, so it's +2. Whoops, I started to draw 3 there. That's a 2. +2. And parentheses, because I have more than one of a polyatomic ion. Now, if you look up at the rule says all chlorides are soluble except silver, mercury 1, and lead 2. So that is a solid. And all nitrates are soluble without exception. So I know my nitrate is my aqueous. So this is what we call the driving force for the chemical reaction to occur. This formation of iodine in the one above would be the driving force for that chemical reaction to occur. Okay, so that gives us an introduction, a review of balancing, a review of naming, and an introduction into how to write chemical reactions. So until I see you or we are chatting in class, this is signing off. Love you, kiddos.